Let's talk about how to write the equation of a circle and how to graph it in a coordinate plane. First, let's review the fact that a circle is a set of points that are all equidistant from a center point, and that the radius of any circle is the distance from its center to any point on the circle, which would mean that all of the radii in a circle are equal to each other. Let's call the center of the circle HK, and we could call any point on the circle XY. So XY I have graphed right here, but it could have been any of the points on this circle. And when you connect the center, point HK, to any point on the circle XY, it creates the length R. Every radius of this circle is length R. They're all equal to each other. In other words, they're all the same distance. So we could calculate that distance using the distance formula. The distance between the center HK and any point on the circle XY would be given by this formula. R equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So really the equation of a circle is actually just the distance formula, because all of the points on that circle are the same distance from the center, so we can give that distance by using the distance formula. Now typically, you'll actually see the equation of a circle written like this instead, and all that we've done here is squared both sides. So instead of having this big ugly square root, we square both sides to get rid of that square root, and you end up with r squared on the other side. So when you're looking at this equation, x and y are just any point on the circle, so they'll always just be represented by x and y. H and k are the x and y coordinates of the center of the circle, and r is the length of the radius. So let's write the equation of this circle. The first thing we need to know is the coordinates of the center, and that's this point right here, the point 2, 3. We also need to know the length of the radius, and the easiest way to count that is to count from the center to any point on the circle, but the easiest ones to count to are the horizontal and vertical distances. So for example, from the center, going to the right horizontally, it's 1, 2, 3, 4, 5 units. And you would get the same thing if you counted up and down or left and right. So our center is the point HK, and our radius is R. So in our equation of x minus h squared plus y minus k squared equals r squared, we'll just put in each of these three numbers and get this as our answer. So I have x minus h squared plus y minus k squared equals r squared. And you'll notice I went ahead and simplified 5 squared to be 25. Now don't be confused by the fact that these have subtraction symbols. The subtraction comes from the formula. So even though we had positive coordinates for our center, they'll end up looking like they're negative when you plug it in, because the x minus is from the formula, and then you just put 2 in for h. So let's try another example. The center of this circle is the point -6, -4, so that's h and k. And the length of the radius is 3. So the equation that I would write is this: x minus -6, so that's x plus 6, squared, plus y minus -4, minus minus means plus, so y plus 4 squared, equals r squared, so 3 squared, which is 9. Our next example has a center at the origin, so h and k are both 0. And the length of the radius is 9. So the equation that I'll write is actually just this little guy. You could write x minus 0 squared if you wish, and y minus 0 squared if you wish, but since you're just subtracting 0, you really don't need it, so you can just write x squared and y squared. And then 9 squared is 81, so this is the equation of that circle. You don't even need the graph in order to be able to write the equation of a circle. All you need is the center and the radius. So the radius is r, the center is h and k, so the equation of this circle would be x minus 9 squared plus y minus 5 squared, or y plus 5 squared, equals 7 squared, which is 49. So I want you to pause the video and see if you can write the equation of this circle on your own. Give it a try. What you should have written is x plus 11 squared plus y minus 4 squared equals 36. Our next example is the most basic version of an equation of a circle that you can have. The center is at 0, 0, the radius is of a length 1, so the equation would be x squared plus y squared equals 1. But what if I don't tell you the length of the radius? What if instead I tell you the center and some other point on the circle? Well, since the radius is just the length of a segment that connects a center to a point on the circle, you can just calculate the distance between this center point and this point on the circle. So you could use the distance formula, or you could just use the equation of a circle formula. And I'm going to use the latter. So I have x minus h squared plus y minus k squared. So that's 1 minus 5 squared plus 2 minus negative 1 squared, and that equals r squared. So when you crunch those numbers, you end up with an answer of 25 for r squared. Now you could go ahead and square root that to find out what r is if you want, but when we write the equation of the circle, we need to write r squared. So I'm just going to leave that as 25. So to write my answer, I'm going to take the center that I was originally given and the radius that I just calculated and write this for my answer. Let's try that again. So we don't know the radius of this circle. All we know is a point on the circle and the center of the circle. So we can plug my h and k and the x and y into our circle formula to figure out what r squared is. So I have x minus h squared plus y minus k squared, and I set that equal to r squared. Crunch those numbers, and we find out that r squared is 20. Now remember, you don't have to do that extra step of square rooting. In fact, in this case, if you were to square root, you would end up with a decimal for your answer. But we don't want that decimal. We want what r squared is when we fill out our formula for the answer, so just leave r squared as 20 because you need r squared in your circle formula. So I have x minus h squared, so that's a minus minus, which is a plus y minus k squared, so y minus 3 squared, equals r squared, which was 20. So I'd like you to pause the video and try this next one on your own. Let's see how you did. Plug in those numbers into our equation of a circle formula, and we end up with r squared being 16. So I'll take my point for the center, which is 3, negative 1, and my r squared, which is 16, and this would be the equation of that circle. So let's try graphing this circle. In order to graph a circle, you need to know the coordinates of the center, and you need to know the length of the radius. The center is h and k. Now remember, since the formula says x minus h and y minus k, you actually need the opposite sign of what you're given. So h here is 5, because it's x minus is the formula, h is just 5. And that would mean that k is actually negative 6, because the formula tells you to do y minus, so if I ended up with a plus instead of a minus, it must have been because k was negative. So my center is the point 5, negative 6, and the radius is the square root of this number, because this number is r squared, and I just want r, so r must be 3 units long. So I'll put a point at 5, negative 6, and then I'll count up and right and left and down 3 units and draw my circle. Let's try another one. The coordinates of the center would be the point negative 4, positive 3. It's the opposite signs of what you see. And the length of the radius would be 5, because it's the square root of this number of r squared. So put a point at negative 4, positive 3, and count up and right and left and down 5, and draw your circle. In our next equation, there's nothing being added or subtracted from x, so you can assume that that means that h is 0. So the coordinates of the center of this equation would be the point 0, positive 2, and the length of the radius would be 7. So I'll put a point at 0, 2, and I'll count up and right and left and down 7 and draw my circle. And that's all you need to know about the equations of circles and how to graph them in the coordinate plane. In our next lesson, we're going to learn how to calculate the length of an arc and the area of a sector.